So here's some examples, a couple of examples of operations with complex numbers that I already wrote out. Remember, when we talk about complex numbers, we're talking about this idea of I, and that's just a definition that's going to represent the square root of -1. That's I. And if we square it, we actually end up, if you square something, you usually get what's underneath it, so that's going to be -1. Although these are definitions, these are not operations because we really can't operate under the radical with negative signs, not legally. And then if we multiply -1 times I, we would get I cubed, and that's -I, so that makes sense. And then if I to the fourth would be I squared times I squared, which would be -1 times -1, which seems to be 1. So these definitions work. And then it repeats itself. So if I had I to the fifth, it would end up being just 1 times I to the fourth times I, which would be just I. So it regenerates. So this is I to the fifth, sixth, seventh, and eighth. 9, 10, 11, 12. And notice that whenever we have a power that's a multiple of 4, it's going to be equal to 1. So we're going to use that in a moment. Okay, so let's just take a look at a couple of these. So here's an example of the square root of -49. First thing I do, like when you're peeling potatoes, what's the first thing you do is take out the I. So the first thing I do is I take out the I, and I write this as I times the square root of 49. Remember, I is the square root of -1, so that's that negative part, so that becomes I. And the square root of 49 is 7, so I have I times 7, or I can just reverse that and say 7I. Here's another example. Negative the square root of -54. Well, the first thing I'm going to do is I'm going to take out the I, and the I is this negative part here. This stays the same, so now I've got -I and positive 54, which is the same thing as 9 times 6, because I want to get out the perfect square factors. And the square root of 9 is 3, so now we have -I times 3 times the square root of 6. And usually we put the I next to the square root of 6. Now, sometimes you see some things like this. Here's an example. What is I to the 417th power? Well, we know that these recycle, or these kind of cycle, I should say recycle, these cycle through. So all we have to do is take 4 and divide it into 417. See what we get. Well, 4 goes into 4 once. That's 4. 0, 7. And it goes in there 4 times, and that's 16. So we have a remainder of 1. So when you have a remainder of 1, that means that this is just going to be 1. If we have a remainder of 2, 3, or if it goes in evenly, we'd have a remainder of 4, which means it would go in even. So since it goes in, it's got a remainder of just 1. I can just look at my first one. This is remainder of 1. Two and 3, and a remainder of 4, which means it would go in evenly. So that means it goes in evenly. So this is just going to be equal to the same thing as I. Okay, oh, I'm sorry, I missed that. Okay. So here's another one. Minus I to the 513th power. Now remember, we'll just keep the minus sign. And what's I to the 513th power? So I'll take 513, and I'll just divide it by 4. 4 goes in there once, that's 4. Remainder 1, bring down the 1, that's 11. 4 goes in there twice, that's 8. Remainder 3. And 4 goes in there 8 times. 8 times 4 is 32. So I got a remainder of 1. So if I got a remainder of 1, I'm back at I again. So that's just going to be I. But there's a negative in front, so it's -I. In other words, that much is I, so we carry the negative sign. Sorry about that. I keep working out on my frame here. So again, what we do is we just divide 4 into 513, and we get 1, 2, 8, remainder 1. So that means I'm at I. This is my remainder up here. Remainder 1, 2, 3. If it goes in evenly, it's going to be 1. So that's all you have to do to deal with those, so they're not too bad. Now, cube roots are different. You can take the cube root of a negative number, so that shouldn't be a problem. Okay, now we have just simplification. So here's some examples. Here's an example. I'll look at number 18, I think, here. This is an example of this worksheet we have, and I've got 6 minus negative 4 plus 3i minus negative 8 minus 12i. So this is an expression. It looks kind of complicated, but just think of the I like a letter, like x, and just deal with it like that. That's what I have to do to simplify it. Just like if it's another variable, x or y or z. So if we were going to simplify this, we have numerical terms and so-called variable terms, in this case I terms. So we just remove all the parentheses and combine like terms. So I've got 6. A negative times a negative is a positive 4. Negative times positive is a negative 3i. Negative times a negative is a positive 8. And a negative times a negative is a positive 12i. And I just combine like terms. So my numerical terms would be 6 plus 4 plus 8. So if I add that, I got 6 plus 4 plus 8, that's 18. And my I terms, I have 12 minus 3. So 12i minus 3i is just 9i. There we go. So 12i minus 3i is just positive 9i. Now, when we say this is standard form, when we talk about a complex number standard form, is when we have the number, there's the numerical part first, we call that A, and then BI. And B is usually called the complex part. So this is A is 18 and B is 9. So we usually want to write these in what they call standard form. Okay. And let's try another one. Here's a nice example. So we see something like this. The first thing we do is we take out the i's. So that's going to be 2i times the square root of 81. And then this is going to be plus, and then if I take out this is going to be I times the square root of 121 minus, and I take out the I times the square root of 9. So that's your first step. Just take out those negative signs and make them I. And what's the square root of 81? That's 9, so that's going to be 2i times 9 plus I times the square root of 121 is 11 minus I times the square root of 9 is 3. Now we can take the square root of 9 but not negative 9. That's why we've got to take the i's out. Then I can just, 9 times 2 is 18, so I could write 18i plus 11i minus 3i. And then 18 plus 11 is 29 minus 3 is 26i. So it simplifies quite nicely. So think of it just like a variable.